Hello everyone. So today we will be talking about an important topic. It's called the receiver operating curve or ROC curve. And so the reason that it is important is because a lot of the questions in the exams, a lot of the exams, for example, like the USMLE Step 1 and Step 2, they often have like one or two questions on this ROC curve. So the main idea here that we're going to discuss is to understand the concept of the receiver operating curve so that you can get those questions right on the exam day. So let's just continue talking about it. So we have so what happens in receiver operating curve is that we have the x-axis here, and then with the y-axis. On the x-axis, we plot the 1 minus specificity, and on the y-axis we kind of get the sensitivity. We plot the sensitivity. So sensitivity, we know, yeah, you may know from your biostats course, is that it is equal to true positive divided by true positive plus false negative. So it's basically just the true positive rate. Okay, so now the true positive here will be represented on the y-axis, the vertical axis. Okay, so then we have the sensitivity, the specificity here, 1 minus specificity here. So, and this represents the false positive rate. And you can remember the false positive rate by the specificity, so it involves the specificity. So the false positive rate is equal to 1 minus specificity. Okay, so the p here and the false positive here. So this one plots the false positive, and this one plots the true positive. So now what we need here is then which curve do we need here, along this in this area. So we need something that is towards this area. So for example, the vertical axis. So if we go this way, like up, vertically up, what we're doing here is that we're increasing the true positive rate, okay, or we're increasing the sensitivity. So we want a test with the curve of that test, we want it here, okay, just along the vertical line here towards the leftmost area, and it is vertically upwards. Okay, and then we talk about the specific 1 minus specificity, which is the false positive rate. We want that to be decreased. Okay, we don't want a false positive rate. We want something that that truly uh, uh, diagnose the condition. Okay, tell us about the condition. So we need something that is towards here. Okay, toward in this way, towards the left. Okay, so we need a curve that is more towards the left. So now we now know two things. We need a curve that the curve of that test we need to be as high as possible up here, as high as possible. Okay, and also as to the left, as to the left as possible here towards this corner. Okay, so now a perfect test then would be something like this line. So now we have this and this. This is a perfect test. Okay, so look, we are operating here. So false positive rate is here. Okay, so let's say the false positive rate is here it will be really low, right? When you go this way, it will increase. So this test is the perfect test now. Okay, then let's take an example of another test. Okay, so let's say this is another test. So this test will be it will not be as accurate as the first one, and the reason for that is because as you're increasing the true positive rates, you're also actually increasing the false positive rate. So they can kind of like it's not better than that. Here we're not increasing the false positive rate. The false positive rate is decreased. So the false positive rate in the first one is here, and in the second one it will be like here. So the false positive rate is increased, okay, and then here it will be here. So the false positive is a lot, like increased a lot in the second test. Okay, so it is less accurate than the first one. Then a useless test, this will be a useless test. So this is a proportional like kind of a curve. So every time you're increasing the sensitivity, you're also losing the specificity here, okay, or you're increasing the false positive rate. So when you increase the false positive, which means the specificity, you're kind of losing the specificity. So it's a useless test. Okay, so now let's understand this 1 minus specificity. So So if false positive rate is equal to 1 minus specificity, so if we go this way along the x-axis, which means that we're increasing the false positive rate, or we're increasing these two, okay? These two go together, so we're increasing them. So how are we going to increase them? We can increase them by decreasing the specificity, which means if we go this way and we increase the specificity, we go this way, we increase the false positive rate, we increase this whole thing, we have to decrease the specificity. So for example, so if we have a specificity, let's say, of 50%, so if this is a 50%, then we will get the false positive rate as 0.50, right? Now, let's imagine like we want to increase this, okay? So if you want to increase this, we have to decrease the specificity. If we want to increase the false positive rate, we have to decrease the specificity, okay? So let's say now the specificity is let's say 30%, okay, or 0.30. So here now we have the false positive rate is kind of increased. Now it's 70, okay? It's 0.70. So this is the idea. If you go this way, you're decreasing the specificity, you're increasing the false positive, so it will use less test. And if you go this way, the more, so if this is the corner, the top left upper corner, the top left corner, the top left corner here. So any test that is closer to or is touching that will be a perfect test, okay? You need the test towards this area. You need to go towards the top left corner. And so then the test which has the most area under the curve, okay, so now if this is a test, this is the one test, and it's area under the curve like here, and then this is another test, this is area under the curve, this whole thing, it means, so any test which has more area under the curve will be a better test. So this test, the first one, will have low area under the curve. The second one will have more area under the curve. So the second one will be a better test here. So that's another. So now let's talk through an example. So let's say in the exam they give you like a curve like this, then another curve like, let's say like this, and then another curve like this, and then they tell you which one of these is the best test. Like you want something that will have the maximum true positive and the maximum true positive and the reduced false positive rate. So you're gonna choose this line because of what we already talked about. Why you're gonna choose this one, because it is to the left, it is closer to the top left corner, and the sensitivity here is increased and the false positive is decreased. So hope this was helpful, and yeah.